Okay, guys, here's where we were. Oh, nice of me to put that down. Okay. I had our list, and then this is what happens when I had not been able to show you this properly, but it plotted the points that I put in the list. Okay, similar to how we plotted right here. Okay, we plotted the points. That's how it looks when we do it. The calculator plotted the points, and that's how it looks when it does it. Okay, now this was the equation that the calculator came up with. Remember, we went, first we put the list in, like we said edit, and we put the list in, right? You saw me do that. The next thing you do is you go to stat and you say calculate the quadratic regression. And so it gave us the ABC, which I wrote down here. I didn't write the whole number, sorry, but negative 0.0111 was A, 1.05957, I stopped there, was B, so that's AX squared plus BX plus C was 0.2421755 is what I wrote. Okay, that's their equation. Okay, so what I did was put that in. So where I went to y equals negative 0.0111 x squared plus 1 x plus blah, blah, blah. Okay, that's my y1. Okay, and what I'm going to do is graph that right on top of those lines. Look how well the calculator did with matching. Okay, the equation, y equals ax squared plus bx plus c, that's how it matches. Not bad, huh? Okay. The equation we came up with was y equals negative 0.01125 x minus 47 squared plus 26. We did it in vertex form. Let's see how that one does. I'm going to turn this equation off. The other equation down here, y2, I put this in, negative 0.01125 x minus 47 squared plus 26. Let's see how well that one does. We'll graph that beside it. We did pretty well too. Maybe we were a little high. We made sure this was the vertex, This was the point that was on it, right? The 7, 8. Okay. Ours wasn't too bad either. So I'm just showing you how close we got by eyeballing it on a piece of paper and to compare to the calculator. Let's graph it at the same time. I'll turn this one on again. Okay. Here's the calculator version, not our version, but the calculator right on top of ours. Theirs was just a little under ours. I think we did a pretty good job. Okay, but the calculator does a nice job as well, obviously. So now what I would like to do is look to see, I'm going to see what we get when we put 80 in for each of these, okay? So, table. No. There's a way to get just the table. That's not it, obviously. That's not it. I can't see. Okay. Oh, it's right here. Okay. So we wanted to know what happens if x is 80, correct? When x is 80, y1 will be what the calculator says 80 is. y2 will be what we say 80 is. Okay, the calculator says 13.968. We said 13.749. What did I say? 13.75 because I rounded. And it's pretty close. I just wanted you to see how close we can get compared to the technology that's out there. Okay? All right, I am going to show you how to do it on Desmos as well. Okay, so we get Desmos up. And the first thing we're going to do, a little bit different, we're going to click onto this plus. We haven't really done that. And then we go down to the table, and we enter our data, the same data that we had before. The x coordinates were 7, 20, 33, 47, 60, and 67, The y coordinates were 8, 15, 24, 26, 24, and 21. And we're going to put the plus again and say we would like an expression. This part's a little different. We have to type, see how they do x1 and y1? So we're going to say y1. I didn't have to do subscript or anything. I just typed y1. And then the little tilde. It's right to the left of the 1 up top is this little tilde. And we want to type in our standard form of the quadratic equation, which is ax squared, but I have to type x1, ax1 squared plus bx1 plus c. Okay. Well, that doesn't quite look right. 7, 8, 20, 15, 33. Sorry. Here's the points plotted. 7, 8, 20, 15. I had to hit a little button that said zoom fit over here. Silly me. I went up here too quickly. Forgot to fit it. Okay, the expression, like I said, we're going to write y1 tilde, and then we write ax1 squared plus bx1 plus c, and it's tried to fit it as best it could. Okay, pretty close like ours was. Notice what their A, B, and C are. Very similar, negative 0.01111. B was 1.05757. Okay, C was pretty close to what we had. Okay, so all of these methods are there. There's technology ways to fit a parabola. We can use Desmos. We can use our graphing calculator, or how great was it that what we did in class with the vertex form was pretty close as well, wasn't it? Okay, we knew the vertex was 4726, so we wrote y equals something times x minus 47 squared plus 26. We used another point that was close to the graph as our xy. We used 7, 8, and we found an equation that matched it pretty closely as well. Okay? So you can use whatever you like in order to try to match the other parabolas, the other examples that I have for you. Okay. I think there are 3 more examples. Let me pull those up. Okay, we did this one together. We have 1, 2, 3. Okay, and here are some directions on how to do it with the graphing calculator. I'll try to post some directions for Desmos. You can always just rewatch the video of how I did Y1, etc. Okay, and Desmos shows you as well. There's a help button there. Okay, and so that's your assignment for this week, guys. Model these expressions, graph them. I have the graphs drawn for you. Be careful because the x and y axes are sometimes off, okay? Here on the x-axis, I was going by 0.25s. At the y-axis, I'm going by 5s. So you'll have to just be careful and make sure that you're plotting things correctly. I tried to help you with that. Okay? Bring that to class with you. All right? This is another bring to class type deal, okay, where we'll work on it together a little bit, answer your questions, and give you a chance to hand that in, okay? But make sure that you're working on these. They take time, all right? And I want to kind of talk about who did it on Desmos, who did it on the graphing calculator, who did it by hand. It'll be interesting for us to debate that in class. All right? Have a great rest of the week, and I will see you next time that you're in Carlisle High School. Bye-bye.